G'day everyone, so in this video we're going to be finding unknown side lengths that aren't the hypotenuse using Pythagoras' theorem. So just remember, for the hypotenuse we use c squared is equal to a squared plus b squared. Okay, so whenever we're finding a side length you can rearrange it beforehand, you don't have to, but if you rearrange it beforehand you have a squared, so this is the side length, is equal to c squared. Okay, just remember this c squared, this is our hypotenuse. Okay, so this one here is our hypotenuse, and then minus b squared, the other side length. So we're going to work out these questions here using this method. Alright, so first off we'll start with a. So what you need to do is identify all the side lengths that you know. So I'm just going to write a squared is equal to c squared minus b squared. Okay, so with this a squared, this is what we want to find out. It's a side length that isn't the hypotenuse, so we'll keep that the same, a squared. So c squared, this is always our hypotenuse, so our hypotenuse in this first one is 25. Okay, so this is going to equal 25, and then b squared is just the other side length, so this is going to be 24. Oh, sorry, I should say 25 squared. And then minus 24 squared. So with this, you just need to work these out. So 25 squared, or a squared, is equal to 625. And then 24 squared is 576. So with this, you just minus these from each other and you'll equal a squared is equal to 49. So now we need to get a by itself, so we square root it. Okay, that's the opposite of square, so a square root of 49, which is equal to 7. Okay, so that's how we work out a. Okay, b here, this one is pretty similar, except for we need to work out with a decimal. So you actually use the exact same method here, and I'll just do this a little bit shorter. So we have, I'll just do this up here. So we have a, so that we'll just call this a squared still, is equal to 12, that's our hypotenuse, minus 6.2. Okay, so with this, we just need to work out these values. So a squared is equal to 144 minus 6.2 squared, which is 38.44. So this all equals a squared is equal to 105.56. So then we square root both sides. Just need to come down here a little bit. So this here is equal to 10.27, and it says round to 2 decimal places, so it's 10.274, so I can just write 10.27. Okay, so just write it out again, clearly state the answer because this variable is b, so I'm going to write b is equal to 10.27. So you don't need to change your answer until the end. Okay, always like highlighting your answer as well, just to make it very clear on what your answers are. So this last one, this one's a bit trickier. Okay, so for C here, we need to identify a little bit of information. So with this, we're given that these two sides are the same, shown by them. Okay, so the same symbol means that they're the same side length. So we can write that x squared, and I'm going to go back to our original formula here. Okay, so c squared is equal to a squared plus b squared. So we can say our hypotenuse squared, which is 7 squared, is equal to x squared plus x squared. Alright, now this brings in a little bit of algebra. So 7 squared is 49, okay? And this is equal to 2x squared. So with this, we just need to divide it both by 2. So 49 over 2. So we're dividing both sides by 2 to get rid of the 2 and the 2x squared is equal to x squared. And now I'm just going to switch the sides, so we need to square root both sides though. So x is then equal to the square root of 49 over 2. And we actually leave it like that because we read the question, give an exact answer in part C. Okay, so this is an exact. If you round this to a decimal, okay, this actually doesn't make it an exact answer. So that's how you go about working out these problems. So hopefully this helps, and good luck.